Hello everyone, I'm Sweet Valberry, and welcome to my ComfyUI course series, launched in collaboration with Olares. In our previous lessons, we have learned how to build, review, modify, and run workflows in ComfyUI. In this lesson, we will put these foundational skills into real image generation practice. We'll systematically explore and implement the complete process of image generation, including text-to-image, image-to-image, image editing, in-painting, out-painting, and image upscaling. Throughout this process, we will encounter many mainstream models and tools, such as image generation models like Krea and Qwen-Image, control and reference signal models like ControlNet and Redux, image editing models like Context and Qwen-Image Edit, image upscaling models like Seed VR2. For many learners, their first exposure to AIGC begins with seeing stunning images generated by others, realistic portraits, stylized illustrations, cyberpunk cities, abstract art. Indeed, images are the most shareable and eye-catching results, making image generation the most fundamental and intuitive aspect of AIGC, as well as the most beginner-friendly direction. When we talk about AIGC image generation, strictly speaking, we're referring to generating images using diffusion models. To put it a bit more technically, this means performing the denoising process of a diffusion model. Starting from a completely unrecognizable pure noise image, the model gradually removes noise step by step until a complete image is formed. Today, let's start by building this process step by step in ComfyUI. Create a new blank workflow and add a sampling node called KSampler. It's the core node in almost all image generation models. This is the standard version, but there are also advanced versions like KSampler Advanced, as well as custom version the Sampler Custom and its advanced counterpart, Sampler Custom Advanced. These four nodes mainly allow control over the generation process at different granularities. Of course, the finer the granularity and the more conditions available, the more complex they are to use. To make it easier to understand the logic of image generation, let's begin with the most basic version. We'll discuss the parameters in the node later, but first, let's look at its inputs. First is the model. Currently, there are many different image generation diffusion models, each with its own strengths, and we need to select them based on different scenarios. Model loading methods also vary, but the most common is the Load Diffusion Model node. For this demonstration, let's use the popular Krea model. Modern models are getting larger and larger, but GPU memory is limited, so typically different quantization formats are provided to allow for smaller model sizes. For example, the default Krea model is in BF16 format, occupying 23.8 GB. Here, I've chosen the FP8 format, which reduces the size to 11.9 GB. Alternatively, you can use the original version of the model. Just select FP8 for the weight detail to achieve the same reduction in VRAM requirements. The second core input for sampling is the prompt, both positive prompts and negative prompts. During the diffusion sampling process, the model moves towards positive prompts and away from negative ones. Earlier diffusion models, such as SD1.5, supported a tag list style of prompts, which could only enumerate elements, making it difficult to express complex actions, relationships, or emotions. With the advent of stronger text encoders and richer training data, the new generation of diffusion models can truly understand prepositions, scenes, actions, and hierarchical relationships in natural language. You can now freely and confidently describe the scenes you want to create. Some recent Chinese open-source models even support multi-language prompts including Chinese and can directly generate poster text. Additionally, new distilled or accelerated models, such as the current Krea dev, often downplay or even ignore the effect of negative prompts for speed. Therefore, it's common to leave the negative prompt field blank. The model cannot directly recognize our prompt text. It must first pass through a text encoder to be converted into a vector. To do this, connect a dual CLEP loader node to the left of the prompt node, which loads the dual text encoders used by the Flux Krea model, CLIP-L and T5XXL. Since T5XXL is quite large, I've used the FP8 quantized version here, which reduces the size by half and helps save resources. Set the type to Flux. Since we don't need to input a negative prompt, just click the small dot in the upper left corner to collapse that node. The final external input for the sampling process is a blank latent image, generated by the empty SD3 latent image node. Since Krea is a 16-channel model, we select this one. You'll often see the default node, empty latent image, but it's a 4-channel node suitable for earlier models. Of course, you don't need to worry too much. In text-to-image sampling, even if you select the wrong node, ComfyUI will automatically convert the initial noise image to match the model. This node also lets you set the final image size and count. Using the default value, it will initialize a Talon 24 by Diaming 24 square image. These 3 items, model, prompt, initial latent image, are all that's needed for image generation. Whenever you use any diffusion model for text-to-image, you only need to provide the corresponding inputs to generate an image. Now let's look at the parameters inside the sampling node. I'll set them to commonly used values and then explain each one. The seed determines the noise distribution in the initial image, thus affecting the sampling results of the model. By keeping the inputs and parameters unchanged, changing the seed gives you different results, commonly known as drawing a card. Here, I've set a fixed value 77 and fixed the seed, to more conveniently compare the impact of different parameters. Sampling steps, sampling method, and scheduler are 3 key parameters that should be considered together. The sampling method determines how each step is updated, the scheduler decides how much noise level is processed at each step, and steps dictates how many iterations are performed. With the Krea model as an example, Euler combined with the simple scheduler can converge to a clear image in just 20 steps, with little change beyond that. Meanwhile, the combination of Euler A and the beta scheduler is a slower, smoother curve, often requiring 30 or even 40 steps to slowly refine that soft, delicate texture. Guidance strength PCG and denoise strength are both set to 1, but their meanings are quite different. With Krea being a distilled model, negative prompts are ignored, so using a high PCG does not help. Setting it at 1 maintains stability. Denoise strength of 1 means the goal is to replace 100% of the initial noise with a completely new image, which is a must in text-to-image generation. We'll dive deeper into the effects of different values for these parameters in the image-to-image section. After sampling, we get a new latent image. We still need to use a VAA to decode it to obtain a real image in pixel space. Just as with CLIP, different models require different VAEs. Authors usually specify the required VAE when publishing their models, so make sure not to select the wrong one. Finally, let's add an image saving node to display and save the final image. A basic image generation workflow is thus complete. Click Run. Wait a moment, and we've obtained this highly technological-looking portrait. However, this is just the basic workflow we could also complete in SD-WebUI or ForgeUI. In ComfyUI, we can use various nodes or plugins to closely observe and intervene in the internal steps of sampling. Create a new sampling node that can display the image's evolution during the process. This node is part of the third-party Inspire Pack plugin, which can be searched and installed via the manager. Connect all the previous inputs to this node, and switch the output option to all images during the process, to output every image at each step of sampling. Keep the parameters consistent with before. Note there is a noise mode parameter in the node. Here, you should select CPU to fully reproduce the previous result. This is the default method in ComfyUI, different from SD-WebUI, which defaults to GPU. It helps maintain consistency across different devices. Click Run. Sampling takes about as long as last time, but the VAE decoding time will be noticeably longer. That's because, this time, we need to decode 21 images in total, the initial noise plus the 20 intermediate steps. The first image is the initial pure noise image. It is determined only by the seed and image size, without containing the semantics of the prompt. Subsequently, with each step, the noise gradually decreases. In the early stages, it mainly establishes the composition and large color blocks. During the middle stages, it refines shapes and lighting. In the later stages, it fine-tunes local textures and contrast. Finally, it generates an output image identical to the previously established one. In ComfyUI, we can also use the advanced sampler to actively switch conditions during the sampling process. For example, in the first 10 steps, import a blurry reference image to lock in the composition. Then, starting from step 11, remove the reference image and load a LoRA specializing in fine details to achieve sharper textures and higher quality in the final result. This mid-process strategy is difficult to implement in traditional front-ends and is one of the signature features of ComfyUI workflows. This process is compatible with most generative models. Now let's switch to a model that supports Chinese prompts and try Qwen-Image. Step 1. Download the model file along with the corresponding text encoder, clip T5, and VAE. Specifically, the three required files are one for the model, one for the text encoder, and one for the VAE. Place them in the diffusion models, text encoders, and VAE subdirectories under the models directory respectively. You can choose different quantized versions based on your VRAM and quality requirements. Here, I'm using the FP8 quantized versions of both the model and text encoder. Next, modify the workflow. Replace the model in the model loader node with Qwen-Image. Since only one text encoder is needed, delete the previous dual clip loading nodes and use a single clip loader instead. Load Qwen 2.5 VL and set its type to Qwen-Image. Also, replace the VAE with a corresponding Qwen-Image VAE. Different models prefer different parameters. For example, Qwen-Image works better with a slightly higher FCG, so here we set it to 2.5. Keep the rest of the parameters unchanged. Enter a Chinese description as the positive prompt. Since I want to generate a poster, resize the image to a vertical format, 156 by 1584. Click Run. After about 3 minutes, we get this poster in a playful and cute style. More importantly, the text recognition is highly accurate, with almost no errors. This is Qwen-Image's advantage in rendering Chinese text, which other models struggle to match. Now switch back to a standard sampling node, remove the nodes for saving intermediate images in the sampling process, and revert to the Krea model. Adjust the parameters, and let's continue the demonstration. Sometimes, we need to generate images of specific characters or styles, but relying solely on the input prompts, the model can hardly grasp our exact intentions. There are various ways to achieve this, among which LoRA is one of the most stable and reliable. Add a LoRA model loader node between the model loader node and the sampler node to load a LoRA model specialized in artistic image style. This will impart distinctive stylistic features to the generated results. Note: after downloading the LoRA file, place it in the model's Olares directory. The Olares release page usually provides detailed usage instructions, including the base model it adapts to, recommended parameters, and key trigger words. Let's modify the positive prompt. Insert the Olares trigger word at the beginning of the existing content. After generation, the image will distinctly exhibit the oil painting style, which is significantly different from the previous photorealistic style. If you need to use multiple LoRAs simultaneously, simply add another LoRA model loader node and fill in the trigger words accordingly. Besides the style LoRA I just demonstrated, there are many types of LoRA. Some focus on specific character reproduction, some provide special effects, and some can even accelerate sampling. The usage process is generally similar. Download the model, place it in the model's Olares folder, load the models, enter the trigger words if needed, adjust parameters if needed.